Johann Dobereiner observed similarities in properties among groups of 3 elements called triads in the early 1800s. The middle element in each triad had an atomic weight approximately halfway between the other 2 elements. However, Dobereiner's Law of Triads was dismissed as a coincidence due to its limited applicability. A.E.B. de Chancourtois arranged elements by increasing atomic weights on a cylindrical table, but it gained little attention. John Alexander Newlands proposed the Law of Octaves in 1865, where every 8th element had properties similar to the first. Newlands' law was analogous to the repetition of musical notes in octaves. Although Newlands' law was limited to elements up to calcium and initially faced skepticism, he received the Davy Medal in 1887 for his work. Dmitri Mendeleev and Lothar Meyer independently proposed the periodic law in 1869. They suggested that arranging elements by atomic weights reveals periodic similarities in physical and chemical properties. Meyer observed a periodically repeating pattern of physical properties against atomic weight, noting changes in pattern length. By 1868, Meyer developed a table resembling the modern periodic table. However, Mendeleev's work, published later, is credited with the development of the modern periodic table. Mendeleev's periodic law stated that elements' properties are a periodic function of their atomic weights. Mendeleev arranged elements in a table based on increasing atomic weights, placing similar elements in the same group. His classification system incorporated a wider range of physical and chemical properties than Meyer's. Mendeleev used empirical formulas and properties of compounds to identify similarities and classify elements. He occasionally disregarded strict atomic weight order to maintain similarities, such as placing iodine in group 7 due to its similarities with fluorine, chlorine, and bromine. Mendeleev predicted undiscovered elements and left gaps in the table, correctly anticipating gallium and germanium. His bold quantitative predictions and their subsequent success made Mendeleev and his periodic table famous. Mendeleev's periodic table was published in 1905. Mendeleev's periodic table revolutionized the understanding of elements and their properties. His table provided a systematic arrangement that grouped elements with similar properties together. Mendeleev's classification was based on the periodic recurrence of properties and allowed for the prediction of unknown elements. He successfully predicted the existence and properties of gallium and germanium, which were discovered later. The predictive power of Mendeleev's periodic table solidified its significance and established Mendeleev as a prominent figure in chemistry. His work demonstrated the fundamental concept of periodicity in the properties of elements. Mendeleev's periodic table laid the foundation for further advancements in chemistry and became the standard representation of elements. It facilitated the organization and understanding of elements, their atomic structures, and their chemical behavior. The periodic table continues to evolve with the discovery of new elements and the advancement of scientific knowledge. Mendeleev's contributions to the field of chemistry, particularly his development of the periodic table, remain enduring and influential.